Good morning, B-Sides, Columbus. Welcome to the Blue Team session. PowerShell, pew, 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 skills for the Blue Team. My name is Ashley McGlone. I'll be your tour guide today. Are you tired of the red team taking your lunch money with commodity PowerShell attacks that have been available for several years now? Quite common. And I'm going to show you a way that you can turn on the black light, so to speak. You watch these CSI shows where they have the black light that shows you all the evidence. Well, here we go. We're going to show you some evidence today with PowerShell. A little bit about myself. My name is Ashley McGlone. I live here in Columbus, and my resume includes companies like Toyota and Microsoft and now Tanium. And so that's where I've been now for about 3 years at Tanium, doing security at scale. So let's dive right in. So today we're going to talk about how did we get here with PowerShell malware, and then we're going to look at the Windows PowerShell policies, and then also want to talk about PowerShell Core, which is the cross-platform PowerShell, how you can do the same policies there, because PowerShell Core has been out for several years now and starting to gain some momentum, and we don't want attackers bypassing your traditional Windows PowerShell policies for Core. So I want to show you how to do that as well. And then I'll share some free resources with you at the end, as well as a demo in there. So a brief history of PowerShell security. How did we get here? So 2003, PowerShell was announced as Project Monad at the PDC, Professional Developers Conference, years ago, 17 years ago, wow. So 2006, PowerShell 1 was released. 2008 was the first security-oriented blog post from the PowerShell team at Microsoft. And basically the point was that execution policy in PowerShell is not a security feature, all right? It's easy to bypass. It's designed that way out of the box. And you can check out that blog post for more info. 2008, 12 years ago, all right? 2013, another blog post, PowerShell security best practices coming out of Redmond, all right? 2015, this was massive. If you've not read this blog post yet, you need to go find it. PowerShell Hearts the Blue Team. This was written by Lee Holmes when Windows 10 dropped, and they put in a massive amount of logging and fingerprints so that you can track exactly what's happening in PowerShell. This is huge. There were some earlier attempts at this, but this became de facto standard out of the box with Windows 10 and available down level on older versions with a Windows Management Framework install. Massive 40-50 page white paper. I want you to go read that because that's a foundation for a lot of what we're going to do today. And by the way, if you've not seen Lee Holmes' DerbyCon talk from last year, I would encourage you to check it out too, because he tells the story of how we got to this point of wanting to make PowerShell a better world for everyone. But that same year, 2015, PowerShell Empire premiered at B-Sides Las Vegas. Most likely this is in your daily toolkit. PowerShell Empire was a framework that would allow you, as a plug and play framework, that would allow you to extend it with additional toolkits, and made it really easy and really turned PowerShell malware into a commodity. And after that, then we saw another blog post from the PowerShell team. This was Paul Higginbotham and Lee Holmes talking about a comparison of shell and scripting languages, proving that green bar across the middle that PowerShell is the most secure solution out there, really, when it comes to scripting languages. And I'll talk about this a little bit later, but in environments where leadership decides, hey, we need to turn off this PowerShell thing, I heard it's bad, and just shut it down across the entire environment, what that's telling, or really what that says is, hey, let's go use some other unsecure scripting or automation framework that we can't track. So you don't want to do that. You want to actually use PowerShell to your advantage in that way. And then in 2017, Matt Graber, a popular security researcher, he says, look, because of this new logging, it is so good, I'm moving on to other language where they can't track me, right? And the industry kind of followed. And the other point that he made there is, look, you can burn PowerShell with fire in your org, but that doesn't bother me. PowerShell is not the reason people get owned. Okay, PowerShell is usually not the point of entry. Maybe it's dropped in a phishing attack, but it's not the point of entry typically. And so that's what you need to keep in mind. PowerShell itself is very secure, but when people misuse it, that's when it becomes a problem. That's what we're going to talk about here. So 2018 PowerShell Core was released. This is cross-platform, Windows, Mac, and Linux, and it has the security policies built in that we used over on the Windows side as well. So those policies are still there. We're going to walk through each of those. Last year, the announcement came out by Zoyer that PowerShell Empire is officially dead. And at the same time, you saw a number of new tools emerge. However, there is another group that has, obviously PowerShell Empire is open source, it's out on the web. There's another group that's got a repo that they're continuing development on PowerShell Empire, but the original founders of it declared it dead. But it's not dead because in the headlines every day of the week, you can still read where PowerShell script is quite common in malware attacks today across the enterprise, across the entire industry. So because once it's out there and people are going to use the least path of resistance, and PowerShell malware is easy now to obtain and use with little training or effort. So that's why we have to guard against it, right? Also, a lot of people are struggling just to identify malicious PowerShell in the environment. And that's why I'm doing this session today. I want you to know what tools you have at your disposal. This tweet by Naked Security said, hey, what if you could eliminate one file type on the network? What would it be? And the majority, 34%, said PowerShell, PS1. We're saying we need to eliminate that. Again, that's the wrong mindset. I want to teach you today how to monitor what's being done in PowerShell so you can use it to your advantage. 2020, this last January, during the Iran cyber attack concerns, there was some guidance coming out of the US CERT that was both helpful and not so helpful. And one, in this US CERT bulletin, on one side, they said, turn off VBScript and PowerShell. Turning off PowerShell is really not the best thing you want to do, like I said. But then they did give you a list of recommendations for mitigation and detection that are all valid. And Lee Holmes says, look, you know, there's a lot better ways to do this. PowerShell can be a great honeypot. And so you don't want to turn it off entirely in the environment. So even as recent as just this last January, I know when I was investigating some of the methods used in these attacks, they were literally just commodity PowerShell with a couple twists. So it was really emphasizing the reason why, even though Empire is dead, we need to continue to investigate and monitor these techniques. So as we get going here, something you need to be aware of is there are different PowerShell editions now. So there's Windows PowerShell, which is built in since Windows 7, 2008 R2, out of the box. But you want to upgrade that. If you've got old machines, make sure you get them upgraded. Windows 10 ships with version 5.1 out of the box of Windows PowerShell. There, okay, being specific there for a reason. That version of PowerShell is complete. Microsoft likes to say that means there's no new development going into it. It's achieved a stability level similar to Python 2.7, where there's not going to be a lot of any real development outside of bug fixes going into that. And so PowerShell Core then is started in open beta in 2016, but then it was released in 2018. Now we're up to PowerShell Core version 7.02 as of this recording. Windows, Mac, and Linux, you can see here in the screenshot, you've got $PS version table will report to you the PowerShell edition and also the version and the platform that you're running on. There are also some variables that will tell you, am I running on Linux, macOS, or Windows here, true or false? So there's OS awareness built into PowerShell Core. And when you install this, and it's also available on ARM. So I've run this on a Raspberry Pi as well. back in 2016 when it launched. So pretty legit stuff. You can actually do PWSH is your shell now. You can run that on Windows, Mac, and Linux. I drive a Mac every day for work, and I use PowerShell quite frequently. I wouldn't say every day, but at least weekly. I'm using PowerShell on my Mac for processing JSON files and different things like that, automating tasks. So this is open source now, PowerShell Core. You can go out to GitHub, PowerShell/PowerShell. And they also have a third Thursday of every month, an open PowerShell community call. Go check it out. You can actually get to interact directly with the product team at Microsoft who's in charge of PowerShell. I would encourage that. So let's talk about how to do PowerShell security then. So that's the background, how we got here. It's a new field. We've got multiple types of PowerShell editions now, not just Windows anymore to be concerned with. And one of the things about that you need to be aware of is they can have what they call PowerShell upgrade attacks as well as downgrade attacks. So PowerShell v2 on Windows 7 did not have the logging we're about to talk about. PWSH, the new PowerShell Core edition, most likely has slipped under the radar and doesn't have logging configured either. So you want to make sure logging is configured everywhere that you've got PowerShell enabled. So how do we do that? So PowerShell hygiene strategy is going to include, number one, making sure all your older machines have at least PowerShell 5.1 on them. So that's your baseline for your older Windows 7 2008 R2 servers. All right. Even your 2012 R2, get them all up to Windows PowerShell 5.1. And then there is an OS feature for the V2 engine. You can disable that. You don't need it. And then what we're going to focus on primarily today is implementing and monitoring the logging and transcription, which is turning on the black light, so to speak, so you can see what's happening. But you also want to use remoting to your advantage, enable that. Uses all the Windows permissions and protections, but also don't forget that in your firewall rules in Windows, you can then allow WinRM port 5985 specifically, requiring that to certain firewall destinations, right? Certain IP ranges, whatever. So you can restrict remoting, and there's even tools within PowerShell to restrict remoting further. And then actually get to the blocking phase, you would use App Blocker, Device Guard, or out of the box AMPC. And also be careful with AMPC because if you're not using Windows Defender, not all Windows AV products will tie into AMPC. That's the anti-malware scan interface. It's working for you every day. And yes, there are bypasses for everything I'm going to talk about today, but a layered defense is your best strategy. So feature matrix, basically what I wanted to mention here, I've kind of covered most of this. The main point here is that the Windows logging and transcription we're going to talk about today are built in on Windows 10 and above, Server 2016 and above, and PowerShell Core when you install it. However, you have to enable the logging. There's an additional step that you have to take, and that's what I'll make sure you take away today. So upgrade your stuff. So real quick, we're going to go through these in a demo in a second, but module logging is also known as pipeline execution or execution logging. And so you're going to see module commands in PowerShell, the parameter binding that happens as they're executed in the logs. Script block logging, you're going to see whole blocks of code as they're executed appear in the logs. Transcription is literally a text file output of what commands were run and what output was generated, and that all of these techniques that I'm explaining to you, those first three, all work on code that was interactively typed or run in memory from an administrative tool or a hacking tool. Anywhere that code executes, it's going to be logged. And then PS readline command history is, PS readline is a module that comes out of the box with PowerShell, and it basically gives Windows folks a Unix-like command history experience that's persistent between sessions. So you can look at that file to see what interactively typed commands could have been malicious as well. And then finally, we talked about anti-malware scan interface. So I'm putting this chart in here for your reference. I don't want to get into the details here too much for the sake of time. We're going to do this in the demo shortly, but suffice it to say there are multiple Windows event log locations, as well as syslog if you're doing PowerShell Core on Mac and Linux. And so there are paths here. You can see where the policy is defined for transcription in the registry, which Windows logs you want to monitor, and which event IDs you want to look for to see where those things are popping in your environment. So policies on Windows, using group policy, you can set these policies under administrative templates for Windows on both the user or computer side. Obviously, it only makes sense to set this on the computer side for all users in the group policy. You go in, set those, and then you'll see there, this is a local version of group policy editor here. But sometimes Active Directory environments are complicated. You've got non-domain machines. And so if you want to automate this at scale, you can simply just run a reg script that will drop the registry values into the policy path under HKey local machine software policies, Microsoft, Windows, PowerShell, and then these different module logging, script block logging, and transcription. So I've got some scripts that'll help you with that in a little bit here. So group policy in the registry or through the GUI tool. PowerShell Core. Now I want to be careful. As I was looking at this in my lab over the last few months, I noticed that when you install PowerShell Core on Windows, this is not a thing on Linux or Mac, but on Windows specifically, you have to make sure whether you're doing the GUI install or the behind the scenes MSI package command lines. This is all documented in a link out on Microsoft on how to install PowerShell. But you want to be careful that you make sure you register the event log manifest. When you look in the PS home directory, you'll see a PowerShell Core instrumentation DLL and the install PowerShell remoting, install PS Core configuration definitions, policy definitions, and register manifest. Those scripts are called when you check these boxes over here in the install or supply these flags. Make sure if you're deploying PowerShell Core in your enterprise that you enable that, because that's going to give you the event log that we're going to look at in a minute for PowerShell Core. So what does that look like in policy then? How do I set the policies for PowerShell Core? All right, let's talk to Windows first. So in the PS home directory, you'll see there's a script, install PS Core policy definition, which has an ADMX group policy template. That group policy template then will add, now notice this is no longer Windows PowerShell. This is PowerShell Core. So they've dropped the Windows name. And so now you have a second location for policies in group policy management called PowerShell Core with settings that you can apply that look identical with one exception. If you already have the policy set for Windows PowerShell, you can simply check a box in each one of these to use the Windows PowerShell policy setting. So it would mirror whatever settings you had configured on the Windows PowerShell policy side. I know that might be confusing. Rewatch the video a couple times if it needs to sink in, but there's now two places for policy configuration because it's no longer Windows PowerShell, it's PowerShell Core. Got a separate place in the registry and a separate place in group policy. So now under policies, Microsoft PowerShell Core, we'll see some of those same settings in the registry as well. Now, if you're doing this on macOS or Linux, and you can even do it this way on Windows PowerShell as well, again, in the PS home, $PS home directory, you look for JSON files, and there's a PowerShell.config.json. If the file is not there, most likely you can create it. And so then in that PowerShell.config.json file, you can provide these settings, which will be in the slide notes later for you. And so this is the JSON saying, hey, turn on script block logging, turn on module logging for all modules, turn on transcription and write it out to this var temp directory, which is a persistent temp, right? That's important there. If you write it, make sure you write it to the correct temp directory that will be persistent. All right. So you can turn on those policies on other PowerShell core as well. Now, I tweeted this screenshot back in December as I was looking with the preview on PowerShell 7, but it basically kind of puts it all together on a Windows machine using the JSON PowerShell config. So under program files, PowerShell, now just /7, no preview. See your PowerShell config JSON file. It's got these policy settings in the JSON. You run your malicious PowerShell command here as an encoded command. And what you see behind you is in the event log, you can see the plain text of the command that was executed behind the scenes, behind that encoded command as the event 4103 or 4104. Then in the PS transcripts directory, I open up the date stamped folder, and in there I'll see files which will have a full transcript of the command, the user it was run under, the process ID, all that good juicy forensic data that you would need to investigate a PowerShell attack. It's all there. This is PowerShell Core, but the same thing applies to Windows PowerShell. Same logs you're going to look for, except the location in the registry is going to, or the event viewer is going to be slightly different. We'll take a look at that. So pro tip here, when you're making changes to PowerShell policy, you need to make sure that you log out of your PowerShell session and open a fresh one, because PowerShell policy settings are cached in the PowerShell session when it's created in memory and when it's instantiated. So if you're changing PowerShell policy settings and you're not seeing the logging happen the way you expect it to, it's probably because you need to exit that PowerShell session and then come back into it. And then as you make changes, you'll see that hit the logs. So that's one important thing as you're working with this you need to be aware of. So let's do some demos here. So let's take a look here at Windows PowerShell. So here I am on a Windows box. I've got the Windows PowerShell command environment, and I've also got the PowerShell core that I'll spin up here. So here in Windows PowerShell, I can type things like get process, right, -ID 0, and there's our idle process. All right, run commands, you know, whatever you want to do. And let's go grab a malicious PowerShell encoded command here. And what we'll do is I'm going to drop this into the command prompt, and I'm going to run it both as PowerShell, which uses the PowerShell engine. Oh, look, it changed my font size. And then I'm also going to run it with a PWSH, which is the exact same kind of syntax here as, let's see, get that in there. All right, so demo fail. Let's pull up a fresh command prompt here. There we go. And let's paste that guy in. Come on, edit and paste. Oh, well, let's try this one last time here. There it is. There's my PowerShell core. So what we've done is we've done an encoded command. We cannot see, if you're using command line logging, all you would see is the encoded command. You wouldn't know what was in there. It's base 64. You decode the base 64, but then it could still be obfuscated. So this is going to show you what happens in memory. All right, so we've run it in both PowerShell core, PWSH, and in PowerShell. So we've introduced some malicious code. Let's go take a look. So you'll notice here in the registry, we have the Windows policy set, for example, transcription, script block logging, module logging. And then up here under PowerShell core, we have module logging, script block logging, and transcription turned on. So those are turned on now. We can go look and see where they occur, but let's take a look also at a couple other freebies we get here. So if I type invoke Mimikatz on a Windows 10 box, See, this script contains malicious content and has been blocked by your antivirus software. I want to point out something. If you don't see this message that has been blocked as malicious, that means that anti-malware scan interface, or AMSI, is not enabled on your machine. Certain third-party AV, if you disable Defender, you're disabling AMSI and you're opening yourself up to this basic protection built into Windows 10. Be sure that your AV provider supports AMSI for that reason alone. So invoke Mimikatz is there. But there's no command on that. Command has no module installed on the machine, but just the name of that command is popular enough that it knows to block it. I also want to show you a PS readline history. So if I say get module, let's see what we've got. Notice PS readline module is loaded in the background by default. It includes some commands, get PS readline option. And we can see the options for PS readline, which include how many history commands to remember, and where am I going to stick this? And the thing I like about this is it puts it in the user's app data path on Windows. It puts it in another location on Mac and Linux. But here it's in my app data path. So now I have a console history session of every interactively typed command in PowerShell. Now, be aware, it's easy to just unload the module when you start your session, okay? If you're malicious, you may do that, but most everyday users wouldn't know to do that. So it's going to record anything that they do. So what I can do then is I can say get content, which is the PowerShell version of cat, and I can tell it to use get PS readline option history save path. So it pulls in the path, it opens the file, and shows me all the commands that were interactively typed on that machine. There's the commands that we just typed a few minutes ago. All right. So that is the only problem with this file, however, is there's no date stamping on the commands that were run. So it is a fingerprint location you can look for PowerShell activity. Just know there's no date stamping in there. So that's running commands on the PowerShell side. So then over here in Core, I can do the exact same thing we just did there. Now let's go take a look under PS transcripts here. Let's start with PS transcript and today's date. And notice here there's a number of transcript files. Let's pick one and see if we got the right thing. There it is. Yep. So if we go in here and we zoom in, let's zoom in and let's take a look. Here's a PowerShell transcript file that shows me date, time it was run, the user context, and if it's a remoting session, it will tell me the user ID it was run under, tells me the Windows computer name. In this case, the host application is the encoded command. Shows me the process ID and all the edition, the version, all that. Shows me here's the actual invoke expression. It's just for demonstration purposes, but this was further obfuscated in the code that it was actually in that encoded command. So while you're looking at invoke expression here, you'll note that in this case, the invoke expression was the result of other obfuscated code, and the output was just pew, 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 PowerShell pwned. And then you see headers here for the time that that command ran. So this is incredibly valuable for forensic information for investigation. You'll see the exact same thing happen with PowerShell Core. It will put it into the transcript path that you specify. Also then in Windows event log, what we want to look at is under the Windows application logs PowerShell. Here you'll see 4103. Let's refresh this view and let's take a walk down through here, these event logs, until we find our PowerShell pew pew pew. And we're looking for 4103, which is module logging, and 4104, which is script block logging. And because I'm kind of doing this demo on the fly, I should probably go back and look for a timestamp maybe. But anyway, what you're seeing here is you can see each command as it's being run, the parameters that are being bound to that command as it's executed for PowerShell parameters. There's our, okay, keep going. There's our invoke Mimikatz output in the console. We'll keep going and we'll look for pew 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 should be coming up. There it is, yeah, 4103. So here's the output of the command in the Windows event log. Here's the same thing that we saw in the transcript earlier, all the metadata about the session that makes it interesting for us. That's in the 4103 module logging. We can also see that in 4104 script block logging. And again, the benefit here is it doesn't matter how the code was executed, you're going to see the output in the logs. Similarly, if I scroll up to the PowerShell Core log here, so under my logs, now I have PowerShell Core on the left as well. If you've installed PWSH, same thing here. I can look at 4103. There it is, pew pew pew. Same metadata. So make sure that if PowerShell Core is being used in your environment, that you install it with that manifest switch so this log gets turned on Windows. And we'll see the same thing with 4104 script block logging. So there we have it on a Windows machine. Now, let's pivot over to the world of cross-platform with a CentOS box here. So here, $PS version table. Actually, I don't have it logged up. So I've got an SSH session to my CentOS box, PWSH. And now I've got PowerShell already installed there. The installation directions are on the Microsoft website or that GitHub/PowerShell PowerShell. And so here I'm running PowerShell now on a CentOS box, PS version table. Tells me this is the edition PowerShell Core. The version is 702, the exact same version that was running on my Windows box. I also have it on my local Mac here as well. So here I am, and what I want to do is change into the $PS home directory, which is the $PS home sends me to the installation path for PowerShell. And here, watch this, just for fun. Normally we would do an LS. I'm going to do a dir on a Linux machine just to mess with people. Star.json, and here is a Windows style directory listing on a Unix box. It's hilarious. Anyway, inside there, for everybody else, I can do ls.json, right? There it is. So PowerShell.config.json, cat that file, PowerShell.config.json, and you'll see here is our policy set on this box with script block logging. We don't do the invocation option typically, but we do enable script block logging. We do enable module logging for all modules here, and then enable transcripting to the var temp, and you just pick your path. PS transcripts is what I picked. So transcription, module logging. Also, so the transcription is going to come out in this path. The module logging and script block logging are going to come out in syslog, which we'll take a look at here. So here again, invoke Mimikatz is not even a thing on Unix platform. There's not that much malware on PowerShell Core, but I expect it to be out any day. So here, we want to run some commands now. Get process ID 1. So now I'm running, just like I run get processes on Windows machines, I can now run it here. And I'm going to exit my PowerShell session, and heaven help us, it won't be that much longer before cross-platform malware will be doing things like this, calling PWSH with the exact same encoded command I did on the Windows machine. And how I've got the malware here, pew 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 PowerShell pwned. It's an encoded command. It's obfuscated in the original code, but now you can see what the output is. So we want to go find that in the logs now. So remember this var temp ps transcript. So let's take that path and drop in there. Now we do an ls because we're back to Actually, we're still in. All right, anyway, we've got 2020, 716. So let's cd 2020. And inside there, I see a number of log files that have been written. So I'm going to cat out PowerShell transcripts, CentOS, and let's look for the most recent one. Starts with a Y on the randomized name. And here we'll see in a transcript on a CentOS box, the same data we saw over on the Windows side. The start time, username, machine name, the host was that encoded command, process ID, and all that goodness. Here's the start time, here's the command, here's the output. It's all good. All right, so that's transcription. Now, for the Windows folks, you might be thinking, well, there's no Windows event log. How do I see what happened? So let's do this then for the event logging. So on Windows, we know 4103, 4104, and the Windows PowerShell or PowerShell Core log. How do we find that over here? So what I'm going to do is I'm going to run over and take a look at the syslog. So I'm going to start up another session. Actually, I'm going to just do it right here. Let's see, pwd $p version. All right, notice I'm not in PowerShell Core right now. It's not tab completing. That's important because if I'm reviewing malware in a PowerShell session, viewing those logs gets written back into the logs, and it becomes kind of a ship in a bottle kind of thing, a nested logging of logs, which is not pretty. So you want to exit out of PowerShell before you do that. But what I'm going to do is I'm going to go to var log, and I can do sudo grep for the PowerShell in the messages file, which is the syslog file, put in my super secret password. And now you can see here in that I've got pipeline details. That's the module logging feature. Invoke expression, and there's pew 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 PowerShell pwned right there. All right, and it also comes out. So that's pipeline details. You also see a script block. Same thing, two styles of logging. Okay, two different options, different policies that we've enabled, and they're slightly different in the output that they generate. But you can see the commands that were executed there. So now for fun, what we're going to do is we're going to tail this, sudo tail -f messages. All right, and so now we're going to go over here to another SSH session on the same box, and I'm going to run pwsh. Notice it just dropped commands behind us in the syslog. And now let's do hello from pwsh. And now back behind us in the log, you'll notice prompt shows up a lot, but here it is right there in syslog, hello from pwsh, as a script block log. And then it's also there as a pipeline details. All right, so that's the two styles of logging. So now you've got it, and I did that on a CentOS box. It's the same on Mac, except syslog is a little different on Mac, but you can still have your transcripts and all that there too. So that's cross-platform PowerShell. I know most of you are probably in Windows environments, and that's your primary concern, but I want you to be aware of the concerns for PowerShell Core that's emerging, that's going to be your next attack vector that the red team could be using against you. So be careful out there. A couple things you need to know before you implement PowerShell logging at scale across your environment. So transcription specifically can cause some issues. And this is not I guess this is really just a core fundamental issue with the operating system, the way some of the transcription works. I've already had a meeting with the PM at Microsoft giving them this feedback. This is feedback that I've seen working with customers, is that If you turn on PowerShell transcription, it will crash Citrix. Not cool if you have Citrix in your environment. All right, they learned the hard way. Active Directory Administrative Center is that little PowerShell-based version of Active Directory users and computers. It'll hang that as well. And if you're using SCOM, some of the management scripts in SCOM can fail if you have transcription disabled. And I saw a note from Microsoft support that said they were going to potentially automatically disable PowerShell transcription out of the box when you install SCOM. So watch out for that. Be careful on that conflict if you use Microsoft SCOM. Also, some older versions of, I use VS Code every day on my Mac to do PowerShell and note-taking and things. There's a script analyzer plugin that happens when you are editing PowerShell and VS Code. That plugin using script analyzer was backed by PowerShell code in the source, which would then cause additional logging to just spam your logs. I've talked with the PowerShell team on that last year. They said they're fixing that. I presume, I haven't checked lately, it's probably fixed by now, but just be aware that if you leave VS Code open with PowerShell in it, it can trigger log writing all day long, even if you're not doing anything in it. Also, I haven't talked about hardening yet. I'll get to that in a second, but you want to harden your transcription directory. If you do that on PowerShell 4, an older version that does support transcription, that's why I don't recommend the older versions. You should be on PowerShell 5.1. But if you've got like a 2012 R2 box that you've turned on PowerShell transcription and you open the PowerShell prompt, it'll just crash. It won't even run. So you can break it. Hardening means setting that transcript directory so everyday users can only write into that directory, but they can't read from it. Only administrators and local system can read transcripts out of there. The reason being is you don't want everyday users on servers or workstations being able to get into those transcript files or those event logs for that matter, because if they can, then they could potentially see secret information that you would put in your PowerShell scripts and run across the enterprise. Now, I know nobody watching this video would ever put passwords into a PowerShell script. However, you might have other things that are, SQL connection strings or, some other type of privileged information that you don't want people to see. So make sure you harden transcripts and event logs. And if you harden the event logs, you have to set it through the registry. I've got a script that'll help you with that. Some editions of Windows that might require a reboot before that hardening would take place. Now, I'm also interested to know from you, what issues have you encountered with PowerShell logging in the enterprise? If you've got any of those, catch my contact information at the end of the deck. I really do want to hear from you because I'm trying to compile good guidance from field experience to help other customers as well. So some free resources for you. Number one, I have created a SPolicy module out on GitHub. Right now, it only works with Windows PowerShell 5.1. It doesn't do PowerShell Core yet. But what it does is instead of, because again, group policy is unwieldy in a lot of environments because it's so long in the tooth, and it's usually most places it's not been managed well, and you've got conflicts of policies everywhere. It's easier to go straight to the registry to set these. So I've provided some scripts for you that will set the policies. Also, it will increase the event log size because the default event log size for PowerShell is 15 megs, and that's not going to hold very much of anything, especially once you turn this on. So you want to increase your event log size. I've seen industry standard guidance that says, set it to a gig so that you've got, and then monitor those logs to see how many days of activity you're getting in those logs. And that's what this SPolicy module is designed to do. It'll also give you the code you need to harden both the transcripts and the Windows event logs, and then clean out those transcript files. If you start writing files to disk and you never clean them, that's going to be a problem one day. Surprise, you filled the disk up. So you want to also schedule a task to clean those transcript files on your endpoints. And then also you want to be able to search across all those logging locations that we looked at in the event of an investigation, a forensic investigation. So I have a script that will do that. However, I put here foot gun warning. You can shoot yourself in the foot this way, because if I'm typing in Mimikatz as my search string and I'm searching that from a PowerShell prompt, now I have introduced the word Mimikatz into the very logs that I'm trying to search for Mimikatz. You see that ship in the bottle, you know, inception kind of problem that we have there. So be careful with that. There's a command here to do it. You should do that, obviously, as you already practice on a machine that's dedicated to investigation, where you don't have to worry about corrupting your own local logs. So this is a work in progress. You can ping me if you run into issues. It's not really released widely yet. I haven't released it on the PowerShell gallery yet either. So I'm interested in your feedback. Give this a try. Let me know if it's helpful to you and your environment. But what it's designed to do is take care of some of the cleanup and nuances around these policies that don't come out of the box with group policy. Also, last year, I spoke at the PowerShell Summit 2019. Unfortunately, it was canceled this year. But last year, I did a hands-on lab going through all of these policies on Windows, and there's a lab on Linux as well. And so there's a guide here on GitHub. You can go check out and walk through building out your own VMs and build your own environment where you can practice with PowerShell policies. And I walk you through step by step in a very teaching method how to do a lot of the use cases that we went through very quickly today. There's a lot of extra tips packed in there that you want to check out. Also, if you're curious, how do I get PowerShell on my Mac or Linux box? There's instructions there at the docs.microsoft.com. Also, I'll provide a PDF of this deck for you out on my GitHub. And as always, you can reach me, ashley.mcglone@tanium.com, or on Twitter at GoTPFE. When I worked for Microsoft, my title was Premier Field Engineer. Now I've left Microsoft and I can't change my Twitter handle. I'll lose a bunch of people. So anyway, reach me at GoTPFE out there on Twitter. And this presentation is not a vendor commercial. It's designed for public education, right? However, that being said, there are some challenges with doing this automation of setting these things at scale. And that's exactly what Tanium does really well. So when I came to Tanium, I brought this knowledge of PowerShell investigation and policy management, and I built it into some content for Tanium customers so that you can set these policies at scale, see where they're set, what the settings are very quickly within a few seconds. And then also, once you've got the settings turned on, how do I keep the transcripts clean, all that stuff, the hardening, it's all taken care of in some content I created on the Tanium platform. But then more importantly is, how do I look for Mimikatz? Again, for example, how do I find that then across thousands of machines in the event logs? We can do that very quickly with Tanium as well. So if you'd like more information on that, you can reach out to me. So besides, this has been fantastic sharing the day with you. I look forward to the Q&A here in a few minutes. Happy to answer any questions you might have there. So in the words of Mark Manasseh, one of our industry mentors on the Windows side of things, use your powers for good and not for evil. So thank you for attending today's session, and I hope to see you in the Q&A soon.